So I'm not Madhur, I'm Matt Urasi. Madhur's having some computer issues. Can you see my screen now?
Yes.
Okay, hi. Today I will present to you on reach-to-grass movements in immersive haptic-free virtual reality. Virtual reality is increasing in our everyday lives and is considered to be a promising technology for physical rehab. However, whether virtual reality supports naturalistic reach-to-grass movements, which are key to numerous activities of daily living, remains an open question. While robotic options to simulate physical properties of objects to be grasped do exist, they tend to be cumbersome and expensive, potentially limiting the usefulness in VR. I'd also like to add, seeing some of the presentations today, that this also has implications for simulation as well. So we're going to today examine the similarity of reach-to-grass motions in haptic-free VR compared to those in the real world. So this is our custom experimental setup. Movements of the participant. Slide is not advancing. Sorry, I'm struggling with this.
Maybe just go out of play mode.
Yeah. Here we go. This is our custom experimental setup. As you can see, the subject is wearing a data glove, there's motion sensors, there's IMUs, and on the right you see the real hand grasping an object in the virtual representation. This is the experiment that was conducted. Subjects reached to grasp 9 different objects at 3 different locations and sizes, in the real world on the left and in the virtual world on the right. In a 2019 JNER paper, we compared the motions, with the most profound finding being that the closure phase, the phase from peak aperture to contact with the object, was most different between the virtual environment and the physical environment. So there's been much attention given to closure. The most robust definition that's been given has been given by Rand et al., that closure is spatially triggered, and the distance at which closure is triggered is dependent upon the transport velocity, transport acceleration, and aperture. So we examined the movements, the closure movement in virtual environment and in the physical environment using this control law. So what I'm presenting here is that the closure distance, the relation of the closure distance in each environment, the physical environment in red and the virtual environment in blue, in relation to each of these 3 variables. And as you can see, in terms of transport velocity, they're extremely collinear, showing that the relationship, though the virtual environment grasped the object at or started closure at a farther distance, it was along the same control curve from as the physical environment. Where we see the largest difference is here in aperture. So the control law was partially maintained in the virtual environment. In the haptic environment, in the virtual environment, there is a need to arrest the fingers to stop on the object, and we believe that that is incorporated into the control law. Again, this is mostly the work of Madhur Mangalam and Marius Furmanek. It was done under the direction of Gene Tu at the Movement Neuroscience Lab, and for more information, please visit our website. Sorry for the technical difficulties.